Hello students, in this lecture I will start the remaining topics. We have already studied till second generation and 2.5 generation. We have covered GPRS, General Packet Radio Services, GSM, and I have discussed something regarding Edge as well, Enhanced Data for Global Evolution. Today we'll start the new technology that is Universal Mobile Telecommunication System. It is also known by the name WCDMA, that is Wideband CDMA or Wideband Code Division Multiple Access. Why it is wideband code division multiple access? Because in CDMA 2000, as in case of CDMA, we have seen that uses a channel of the frequency range of 1.25 megahertz, whereas in under UMTS or wideband code division multiple access, uh, the channel bandwidth is around 5 megahertz. This UMTS will fall under the frequency range of 1885 to 225 megahertz. That is one band, and another band is 2100 to 10 to 2200 megahertz. So this is the allocation. This is the third generation frequency allocation to use along the side with WCDMA. Now, while discussing about GPRS, General Packet Radio Service, so General Packet Radio Service added a kind of a packet switched environment in GSM, because initially GSM was only for voice communication. So to add the element corresponding to data communication, which support the packet switch environment, so GPRS came into existence and it added certain network element to it. So all those things we have studied under the topic GPRS. More or less, the element, the core part is same as we have discussed in second generation technology, particularly pertaining to GPRS. We have seen with certain modifications corresponding to new radio access environment, because here the almost changes just on the radio access environment. Here we are using code division multiple access instead of frequency and time division as the case there in GSM and GPRS. So mm, then once again I want to refresh your memories regarding Edge and GPRS as well. So GPRS, as I have just mentioned, that it adds a kind of a packet switched functionality to GSM network. Now Edge is a higher end version of the GPRS, so with certain more modifications so as to support more speed, more rate of data communication. So how that thing is feasible with certain changes in the radio access environment, and particularly pertaining to modulation and coding technique. So Edge uses a new modulation which replaces GMSK. So initially, so it is starting from the GSM, we are using GMSK, and that persisted with GPRS as well. But here there is a modification. So to improve the speed, rate of communication, rate of data access and data communication, here we are using 8 PSK, that is phase shift keying, instead of GMSK, along with new channel coding for spectral efficiency. That's why it is on a higher end, the Edge is on a higher end, and sometime only because of that, it is sometimes also considered in between 3.5 G as well. Uh, so that is regarding GPRS and Edge. Now we will progress ahead and focus particularly on third generation UMTS. So first we will discuss about the network architecture. The architecture, as I have already mentioned, more or less UMTS is also based on the foundation is almost as we have discussed in GPRS, and GPRS was based on a GSM technology. So if you will see, GSM initially evolved to support the voice communication, and to support the voice communication, the element, core element, only supports circuit switching. So through circuit switching, voice communication was made feasible. Whereas as we progress and came to GPRS to support data communication, there we added the data part to it to support packet switching. So that packet switching element was also there. And two important elements were there in packet switching: serving GPRS support node and gateway GPRS support node. Exactly, or because as I have already mentioned, in case of UMTS network architecture as well, it is also based on the GPRS foundation with certain new element. And what is the new element? Particularly the radio access environment is different, because here instead of FTMA and TDMA and the combination of those, the way we are using in case of GSM and GPRS, that is not there. Instead of that, it is CDMA. So, and in particularly in CDMA, we are based, the CDMA is based on direct sequence spread spectrum. Uh, so that radio access environment is entirely different. So that radio interface is different in comparison to the previous generation GSM and GPRS. That is the only difference. Uh, and certain difference is with respect to terminology. So anything in with respect to GSM and GPRS. So more or less till GPRS, it was consistent in terminology with GSM. Whereas almost they have changed the terminology in case of UMTS design. And why they have changed it is mainly because of the evolution and how the high-end user devices have come up, and there are different technology pertaining to radio access environment and with respect to the core design and all. So they have almost changed from third generation onwards. They've almost changed the terminologies, as it is not consistent with what we have seen in case of GSM and GPRS. More or less the working architecture, the working base, what works each and every network element and entity will do is almost same. So you have to just switch, you have to just emphasize on the new terminology and its corresponding previous term in GSM and GPRS. So if you've been able to equip yourself and comprehend the mapping, that would be enough for you to understand this network architecture. So there are three elements. The constituent element of third generation UMTS network constitutes of user equipment. So what we used to say in case of GSM and GPRS, there it was mobile device, mobile equipment. Whereas here it is not so. It is a user equipment. And why it is so? Because till second generation, the devices were not that good enough, uh, who can process the things fast, where the battery life was more, and particularly the design was based on mobile, on only on the base of voice communication. So that design initially was supporting the voice communication. So the requirement was less. Whereas over a period of time, we have seen the evolution pertaining to hardware and circuit technology, battery life, processing availability. So if you if the user device would get enough data communication speed, then even the application you could have a different kind of application which is entirely way different from the voice communication, and you can do a lot with your mobile devices. So keeping that that consideration in mind, they have changed the name. So they have made it more generic instead of just mobile device just to communicate and just for a voice communication. Here the data communication is also feasible, and it is more prominent from the third generation onward. It is more prominent because users are using device more for the data communication instead of voice communication. So to reflect that thing, to reflect that change, and to reflect that progress, they've changed the mobile device name in their terminology as a user equipment. That is one thing. Another one is the radio network subsystem. As in case of GSM, we have seen the base station subsystem that include the base station as well as the base station controller. Exactly on the same line, they've changed the name just, and the name is now the radio network subsystem. It is to control and manage the network resources, the interface resources. So for all that purpose, this is the name, and it is also known by the name as UTRAN. What does it mean? It means UMTS, Universal Mobile Telecommunication System, a radio access network. So radio network subsystem, and this is more technical. This is more often used. UTRN, UMTS, radio access network, and more or less so the design assumptions are almost same as we have seen in case of GSM and GPRS, where there's a base station subsystem BSS that comprises of two parts. One part is base station controller, which manages several base stations. So several base station falls under the control of one base station controller, and several mobile devices being controlled or managed to their interface, their transceiver are managed and controlled through base stations, and effectively those base station controllers are then managed through mobile switching centers and gateway switching centers in case of GSM, and then along the side of mobile switching centers and gateway switching centers, we have gateway GPRS support node serving GPRS support node for packet switch environment, and these mobile switching center and gateway switching centers are for circuit switch environment that comprises the core part in case of second generation. Exactly on the same line, uh, that also comprises the core part which manages effectively these radio network subsystems and particularly their controllers. So already the core environment, so core environment. So it is just the terms being changed, more or less the design assumption, uh, the design criteria, the working pattern is almost same for each and every network element which is the part of UMTS network architecture. So this is the abstract view you can see. So effectively these user agents have been controlled by RNS, radio network subsystems. So one RNS will control effectively uh, several user agents, and to RNS comprises of two parts. So we can see here RNS comprises of two parts. So this RNS comprises of two parts. Radio network subsystem comprises of two parts. So one part is equivalent. Now I'm drawing the parallels with respect to base station subsystem as we have discussed in GSM environment. In base station subsystem, you have two part base station controller. Corresponding to base station controller, you have RNC, a radio network controller, and effectively the operation as we have discussed in base station controller, it is also going to control the interfaces, the network resource allocation. So So it's going to manage the network resources. Uh, and this RNC is going to be managed by the core network. So mobile switching stations and for, for packet switch to it is serving GPRS, they will effectively manage RNC. But in order to effectively manage the user agent, you have in between. So this RNS is a sort of an interface which will interface in between the user, equipment, and the core environment. So then this RNC is going to monitor several nodes. These node B, so there is a new terminology here for base stations that is called the node B. So third generation onwards, the base stations are to be known by the name node B, and effectively node B are nothing but the transceivers who will interact with the user agent wirelessly. So it's going to provide a sort of an access environment to users, to user equipment. It's going to be effectively in one cell there is a one node P, that is the base station, and different cells being monitored and managed for their network resources by RNC. And there are different RNCs that are going to be managed by the one core environment, core network. And the core network comprises of four parts, as I have seen that later on we will see that what is the part. So that is now we will discuss about the UMTS core part. The UMTS core part is almost same as that of GPRS core part, and almost the terminology is also same. So in order to understand it effectively, here I'm splitting it into three parts. The core part I'm splitting into three parts. One part is that which is going to support the voice communication. That is the circuit switched element. Second part is packet switch element that is going to support the data communication. And the third part is the shared part. There are certain element which is going to be shared. There are certain network entities which are the part of core environment that is going to be shared. For example, home location register, visitor location register, these kind of things are going to be shared by both the elements. So effectively, we can categorize these things, something which is the network element, the core element, which are going to support the voice communication, something which is going to support the data communication, and the one is the shared part, which is going to be shared by both the packet switch as well as the circuit switch to network element. Now the circuit switched element we will see. The circuit switch element is for what purpose? It is for voice communication. And whenever there is a voice communication, so you effectively require a formation of a circuit from starting location to the destination. So from source to destination, you require a effective logical line to establish, a logical connection to establish, and not even logical, but a sort of a physical connection that will persist till the time voice would be there, till the time there would be a communication, there would be a requirement. So for that to be effective in place, you have a mobile switching center. You know the operation, we know it. So mobile switching center, its main job is switching job, and along with that to establish the connection and to know much more about the user who is requesting all these things. It's going to be backed up by the shared resources, home location register, where the location of the destination node is, to know all these things. You know the whole operation, because we have discussed all these things in detail, that what is the job of mobile switching center and how effectively the connection got established from the source location to the last location. So effectively, that is the operation of the mobile switching center. Also in UMTS or Wcdma, Along with that, it is not only that within from one mobile switching center to another mobile switching center, only you're going to be uh, communicating between the two mobile devices. It may be possible that one mobile device wants to communicate to any public telephone, the landline connection, and some other network. So for that purpose, there is a gateway mobile switching center that is effectively a sort of an interface to the external environment. So from your environment, from your network, if you want to sort of an inter-network communication, so for that purpose, you have a gateway mobile switching center. If you want a sort of a intra-network communication from one mobile end to another mobile end, which may be supported by some other mobile switching center, in that operation, in that operation or not only maybe supported by another mobile switching center, maybe another radio network controller, radio network subsystem. So in that situation, our mobile switching center would come in picture. It will effectively uh, come up with a path, a line, physical line, and would then switch our voice from one location to the last location. And if from our location, if we are behind the network and from our end, we want to communicate to some external entity, then we are going to be supported through gateway mobile switching center. Now, the problem with the circuit switch network while discussing GPRS, have already disclosed that you require a physical connection in place before starting communication. So if uh, we are going to use the same line, if we are going to use the same operation of the circuit switched element or the circuit switched phenomena for our data communication, then it would not be effective in place. It's not going to use the network resources so efficiently. So for that purpose, we came up in case of GPRS, General Packet Radio Service. We brought in a kind of a packet switched environment to support data communication effectively. So those elements are almost same. So there is no much change. There is a change even in terminology with respect to WCDMA, and from the third generation onward is more or less in case of radio network environment. Because in case of WCDMA, first important thing is that the radio access environment, the radio access network is entirely different. It is not based on FDMA, TDMA, it is based on CDMA and on direct sequence spread spectrum, spread hopping, DSSS. So, so here we will see the packet switched element, which is going to support the data communication. There's a serving GPRS support node and the gateway GPRS support node. If you know the GPRS working, more or less these are going to support the same operation. So your serving GPRS support node is exactly like as we have seen the mobile switching center in place for circuit switch communication. So if we want to support the packet switched communication for data communication to be more effective and to utilize the network resources efficiently, we brought in case of GPRS in the same architecture we are still using in WCDMA, that is serving GPRS support node. It's going to provide you the mobility management. So wherever you will go, it will keep track of you because this is the node which would consult the shared resources, home location register, visitor location register. So your serving GPRS support node would always be in communication with the shared resources for your authentication purpose, for security purpose, and for all those things. Then the session management is going to manage your session. Then for billing purpose and interaction with other area of networks. So more or less it is the same operations as we discussed in the GPRS. So once again, I won't dwell on these things. So this is the effective operation which your serving GPRS support node would provide. Then there is a gateway GPRS support node. So if you will draw the parallel with respect to the circuit switch, it is more or less like the gateway mobile switching center, but just the difference is that it's going to interact with other uh, packet switch to network elements. So suppose if you have to interact with internet, so that access to internet would be facilitated through gateway GPRS support node. So like the SDGN, this entity was also first introduced into the GPRS network. This is also the part of the GPRS network with the same name, GGSN. So there is no terminological difference in core, whereas there is some terminological difference with respect to the user equipment instead of mobile device. And the second one is in case of the radio network controller, radio network interfaces. There is a difference. Now the shared elements are same. Home location register, you know the different, you know the working that it it contains more or less many of the administrative information about each subscriber, and in this way, if UMTS network is able to route call to the relevant RNC or node B, so each and every home location register will also hold your last location, so that whenever any serving GPRS support node for packet communication, for packet switching, for packet transmission, whereas the voice communication, there is a mobile switching center, they would consult the home location register so that they can probe where exactly you are currently. So that is the home location register, and it also contains many other user profile information as such. Then the equipment identity register. This also, you know that it holds if there are certain devices which you don't want to support in your network, you could have a detail regarding those devices, their make, IDs and all. So here it's going to use the international mobile equipment identity, each and every device. So more or less it is also the same name as we have seen in case of GSM and GPRS. In case of GSM, equipment identity registry is also there, so which holds the international mobile equipment identity, which is a sort of a hardware number of each and every mobile. So if this is just whether you want to allow the device to be uh, served onto the network or not. So for that purpose, we have equipment identity register. The authentication center is for figuring out your keys based on your secret keys, whether you will be allowed or not. So it's a sort of a logical key, and equipment entry is a sort of a hardware key. So based on this information, you will be allowed, and also all these things are going to be held at the time of registration when you will register to the network. This is the overall architecture. So you can see you have, so the first layer is, if you will see even beyond RNS, below to RNS, there is user equipment, UE. So several UE are being managed through RNS radio network subsystem. And then this radio network subsystem also, we have seen it as two-part radio network controller, which is going to manage several node Bs, and the node Bs are nothing but the base stations, and those base stations then further manages different user equipment which are the part which falls under its vicinity, which are the part of the same cell which that node B is operating on. Then these radio network subsystems, their interaction is there for packet switched environment. Their interaction would be there with SGSSN. So this network core element is going to manage RNS, and what they are going to manage, they're going to manage the network resources, because the radio network subsystem is there to manage the network resources, handover, and all those things. So this for packet switch network, SGSN serving GPRS support node is going to manage RNS or interact with RNS. For voice communication, or more precisely and generically to say, for your uh, mm, what voice communication, where MSC is going to come in picture and would interact with RNS and manage those RNS, administer those RNS. And then these MSCs, this SGSN is going to interact with MSC for its operation. MSC is going to interact with GMS if you want to interact with the outside world, outside using circuit switch to network. And then these are the shared resources: authentication center, HLR, equipment identity registers, and there is that is not shown. There is also a space for visitor location register as well. Each and every mobile switching center has its own visitor location register, as we have seen. HLR is common for the whole environment, whereas corresponding to each and every MSC, it's going to monitor who is visiting it. So corresponding to that, each and every mobile switching center would always hold information in their visitor location register, and then other entities in the core environment can access to that visitor location register as well. For packet switch environment, as we have seen, the operation of serving switch, serving GPRS support node and gateway GPRS support node that is going to be interacted with the outside environment. This is the overall theme. This is the overall design on which it is almost, not more or less, it is almost same as we have discussed for GPRS. It is just there is a terminological difference, and so there is no much difference on the core part, because core part is exactly same. There is a difference in RNS, and the user devices are more equipped now. So instead of saying just the mobile devices for communication, as we were using the terminology prior to third generation, here they advanced it to user equipment, rather to say the mobile devices, just to reflect this change, just to reflect this advanced operation which we can do through our mobile devices now. And you have in with respect to this WCDMA, here the radio interface, we are managing it through CDMA. That is the difference with respect to GPRS. That is the major difference. So apart from that, core part is same, everything is same, there is just terminological difference. That's it. And this also I have disclosed that UMT, or radio access environment. So there is a further division to it, RNC and Node B. Already we have discussed. But now there comes a point where we have to discuss, because it's a two-way communication, it's a duplex communication. So now we are discussing particularly the radio interface. So from your transceiver to the base station, where it is the node B. So when the user equipment would interact with the node P, that is the base station, then obviously there are two links, uplink and downlink. So as we have seen in case of frequency division multiplexing, FDD. So what FDD stands for, that there would be two uh, frequencies. On one frequency we will upload the things, and on another frequency we will download. So one frequency is corresponding to the uplink, and another frequency is with respect to the downlink. Now if you have so it's going to give you two choices, and based on our requirement we can use any of these two, that is UTRA FTD, UTRA TDD. So here if the devices are less, and the frequency allocation is more, in that situation we could have a particular frequency corresponding to the uplink and a different frequency. Obviously there would be a gap in between the uplink and the downlink frequency. So exactly at the same time, your transceiver, the transmitter can transmit on the uplink, and the receiver can download on the downlink frequency, because then you just require a filter. which will split the frequency and filter it out for uplink and downlink, so there would not be so much confusion. But the important aspect is, important point is that your frequencies which been allocated to you are lot many, and the limited number of devices which are using that frequency. So in that situation, you can somehow manage through this STD behavior. Whereas if suppose you want to more effectively utilize the network resources which being assigned to you, in that situation, what we can do, the same frequency we are going to use as uplink, and the same frequency we are going to use as downlink. Where we will differ in terms of time intervals. So we will divide our time, and certain times we will give just for upload, and certain time we will give just for download. So there would not be any mismatch. So our transceiver knows the timings, the time slots, the time interval when it has to upload on the same frequency, and your base station, that means the node B, will also use the same frequency. So in this way, we can effectively use the frequency and can support many more user equipment, many more devices. So that falls under Ultra TD, and this Wcdma support both the operation based on the requirement. Uh, it can support both the operations. Okay. Now your user equipment here, it has mm, much more capability. So that radio frequency circuit, so many of the operation, as you know, the many of the operation which initially in case of GSM, and even to an extent in case of GPRS, which being performed, particularly the signal processing things and all, those which used to happen at the base stations and the base station controller. So we have taken many of the operations to the edge. So instead of doing in the radio access environment on base station controller and your base stations, so many of the operations we have taken out, we have drawn, withdrawn from those network entities. And now, because our capability is more, the user device capability is more, so many of those operations are nowadays being performed at the device itself, at the user interface itself. So to support that, now our radio frequency circuitry is also there with support based on what kind of technology we are using. So many of the operations which used to be performed by the base stations now being performed the device itself. So we have somehow relaxed the base environment, the base stations, or in here we are terming it as node B. And baseband processing, that is the signal processing, so already I have mentioned. Now the battery life, so this is important because many of the jobs we are doing, and as we have experience in case of first generation and second generation, we have experienced the battery life. So the same experience the user wants now. So for that operation, to support that kind of a life to battery, we are now many of our batteries are now, and not many, almost all the batteries are now lithium ion based to support the same kind of experience, the overall experience. Then it also supports the universal subscriber module. In case of GSM and all, we were using the term subscriber identity module. Here they have added one more term to it, but almost its operation is more or less the same. It holds the international mobile subscriber identity to support roaming, and as well as mobile station international ISDN number. Other information which use not being supported in case of GSM and GPRS were the SMS. So it is more or less to be said that it has certain memory space as well. which can hold your phone book number certain. It can store certain messages. So whenever you will switch your device, whenever you will switch your user equipment, so all these things comes along with that. That is just the change. But in terms of the design architecture, in terms of the operations which it used to perform, is almost the same. That's all about UMTS, or its other name is WCDMA. Mm. In our next lecture, I will take LTE, and in the same LTE lecture, I will discuss Volt as well. So, hope you will study all these things. If anything you require to ask regarding UMTS, you can mail me, and we can have a session, the doubt session regarding any of the thing which comes in your way and you're not been able to understand and decipher it. Um, so till then, goodbye.